Okay, hello everybody. Today we'll be doing matrices. First of all, let's go ahead and define what is a matrix. In mathematics, a matrix is a rectangular array of numbers, symbols, or expressions arranged in rows and columns. Here we have three matrices lined out, and we'll go ahead and first thing we'll define them. Now, a matrix is defined first by its rows, then by its columns. So, if you look at the first one here, 4102, it has two rows and two columns. Therefore, we call it a 2 by 2 matrix. The second one has 102143. This one also has two rows, however, it has three columns. Therefore, we call it a 2 by 3 matrix. The third one over here, 143107, has three rows but two columns. Therefore, we call it a 3 by 2 matrix. Simple. That's how you define a matrix. Let's go to operating on matrices for a moment. So, first operation we carry out on matrices is addition. Now, in order to add two matrices, they must have the same dimensions. So, you cannot add a 2 by 2 matrix to a 3 by 2 matrix. That will not give you an answer. They have to be the same dimension. So, 3 by 3 or 2 by 2 or 4 by 4, but they all have to be the same dimensions. Now let's go ahead and create two 2 by 2 matrices now. So first one we have here is 4 0 3 2, and we'll be adding that to 7 -2 1 4. Now, to add or subtract a matrix is very simple. You just add the terms that are in corresponding positions. So we can see that 4 and 7 are both in the same position with respect to their matrices. 0 and -2 are in the same position, 3 and 1 are in the same position, and 2 and 4 are in the same position. So we'll just go ahead and add the ones in the same position like how you do regular addition. And so the resulting matrix would look something like this. 4 plus 7, 0 plus -2, 3 plus 1, and 4 plus 2. And then of course the answer to this would be 11 -2 4 6. There you go. That would be what happens if you add them. What happens if we subtract them? If we subtract them, hold on. If we were to subtract these two matrices, it would give us a similar answer. However, we would just subtract the corresponding terms. So just a while ago, when adding them, we added 4 to 7. If we were subtracting, let's say the second matrix from the first, so let's say we subtracted the matrix, what would occur is that we would say 4 minus 7, which will give us -3, 0 minus -2, which will give us +2, 3 minus 1, which will give us 2, and 2 minus 4 is equal to negative 2. So adding and subtracting matrices are very simple. Just make sure they have the same dimensions and then add or subtract corresponding terms like you would do regular addition. Now let's move on to our second operation, which is matrix multiplication. Now this one is can be quite complex sometimes, so just pay attention. For matrix multiplication, it is not commutative, meaning that the order in which they are set does matter. So normally you would learn that 2 by 3, 2 multiplied by 3 is 6, and if you reverse it and say that 3 multiplied by 2, that's also 6. So in multiplication, you normally say the order in which it's set doesn't matter. However, for a matrix, the order does. For a matrix, the order does indeed matter. In order for two matrices to be multiplied, the number of columns in the first matrix must equal number of rows in the second matrix. So let's go ahead and show an example. We have a 2 by 2 matrix, and we're multiplying that by a 2 by 3 matrix. These two can be multiplied because the number of columns in the first one is equal to the number of rows in the second one. Now, if we reverse it and had 2 times 3 matrix multiplying the 2 by 2 matrix, this would not work because the number of columns here is 3 and the number of rows here is 2. So this matrix, this one down here, just would not work. Now, once we sorted out that they can be multiplied, we need to know what is the dimension of the matrix that we're supposed to get. The dimension of the matrix that we're supposed to get is the rows in the first one by the columns in the second one. So if we multiply this by this, we're supposed to get a 2 by 3 matrix. Let's go ahead and do an example of this. So first let's line out our 2 by 2 matrix. And now let us line out our 2 by 3 matrix, which is 1, 0, 2, 1, 4, 3. And now, so we have our 2 by 2, and we have our 2 by 3, and we know that they can be multiplied because columns in the first one equal rows in the second one. And so we know the matrix we're supposed to end up with is a 2 by 3, looking at the outward terms. So what we can do is we can go ahead and we can put placeholders to know where we're supposed to get our answers. So we know we're supposed to get another 2 by 3 matrix, and so we can just put dots in place of the terms to know just where and where we're supposed to get our terms. There we go. Put those implicated terms, and so we know what terms we're supposed to get. Now, let's just go ahead and get this started. Alright, now when doing matrix multiplication, what you're supposed to do is you're supposed to multiply the row in the when doing matrix multiplication, the idea is to multiply the first row of the first matrix times the first column of the second matrix to obtain the first term. To obtain the other two terms in the row, we will multiply the first row times the second and third columns to obtain the other two terms in the first row of the resulting matrix. So, firstly, let's erase this part and go ahead and start multiplying. So first we would say 4 times 1, which is 4, plus 1 times 1. Then we go ahead and we do multiplication by the second column. And we say 4 times 0 plus 1 times 4. 4 times 0 plus 1 times 4. Hold on. Four times 0 plus 1 times 4, which is 4. And then for the last one, we would multiply the first row of the first matrix by the third column of the second matrix. And we say 4 times 4, which is 8, plus 1 times 3, which is 3. Now we move on to the second row of the resulting matrix, and so that brings us to the second row of the first matrix, which we then multiply by the first column of the second matrix. So we would end up with 0 times 1, which is 0, plus 2 times 1, which is 2, then we would now multiply the second row of the first matrix times the second column of the second matrix. That would be 0 times 0, which is 0, plus 2 times 4, which is 8. And then for the last one now, for the third part of the second row of the resulting one, we would do 0 times 2, which is 0, plus 2 times 3, which is 6. Now let's go ahead and rewrite this. Let's make the matrix a little bigger this time. And so firstly we have 4 plus 1, so that's 5. And we have 0 plus 4, which is 4, a plus 3, which is 11, 0 plus 2, which is 2, 0 plus a, which is 8, and 0 plus 6, which is 6. And this would now be the resulting matrix of that multiplication. Well, now let's move on to our final operation, which is finding the inverse of a matrix. Now to find the inverse, we need to find two terms. First we need to find what is known as the determinant, and we need to find what is known as the adjoint. Let's go ahead and start with the determinant first. So let's say we have a matrix A, B, C, D. The determinant of this matrix is equal to AD minus BC. So it's equal to the product of these two terms here and minus the product of these two terms here. We normally say it as product of leading minus product of non-leading. And that's what we call the determinant. Now let's look at the adjoint. The adjoint of, let's say we have the same matrix again, A, B, C, D. The adjoint is equal to D, negative B, negative C, A. So to obtain the adjoint, we swap the leading terms and we invert the signs of the non-leading terms. So D becomes A becomes D, and B and C both become negative. Let's go ahead and try to find the inverse of a matrix we did before. So let's rewrite our matrix from before, which was 4, 1, 0, 2. Let's go ahead and try to find the inverse of this. First things first, we need the determinant. So we look and we see that the leading terms are 2 and 4, non-leading terms are 1 and 0, and so the determinant is equal to 2 times 4 plus, no, 2 times 4 minus 1 times 0. And so we get 8 minus 0, which is just 8. So now the determinant of this matrix is 8. Now let's go and find the adjoint of the same matrix. 4, 1, 0, 2. So we'll go ahead and we would swap 2 for 4 and make the 1 negative as well as 0. However, 0 cannot be negative, so we just rewrite it as 0. 0 doesn't have a sign. And now the inverse is equal to the inverse of a matrix is equal to 1 upon the determinant, which means 1 upon D, times the adjoint, which you write as A. So it's equal to 1 upon the determinant times the adjoint. So let's go ahead and work that out. Alright, so we know our determinant is 8, so we have 1 upon 8, and we know our adjoint to be 2, negative 1, 0, 4. And now we go ahead and we multiply each term in the adjoint by 1 upon 8. So firstly we would have 1 upon 8 times 2, which is 2 over 8. Then we would have 1 upon 8 times negative 1, which is negative 1 over 8. Then we have 1 upon 8 times 0, which is 0. Then 1 upon 8 times 4, which is 4 over 8. And this would be the inverse of the matrix we found before. So yeah, this should be the inverse of the matrix we were using. And of course you can simplify 2 over 8 to be 1/4 and 4 over 8 to be a half. Sometimes it's better when you simplify down to its lowest term. And that's how you do matrices.